Hey everybody, Mrs. Bixler here, and we're about to start Unit 5. Whoop whoop! We're back into proofs. We're talking about parallelism and how that impacts quadrilaterals. We'll get to quadrilaterals later, but we are going to jump into parallelism today. So there are three ways that lines can exist in space. So remember, space is sort of that third dimension that we talked about back in the fall. So the first way that lines can exist in space is they can be coplanar and they can be intersecting. Another way is that lines can be coplanar, but they can be parallel, so meaning they never intersect. And then the last way is this little guy, and this is what we call skew lines. This is when we have two lines that are non-coplanar. So they never really intersect, but just because they're like on top of each other or going kind of diagonal, whatever. So we call those skew lines if they are non-coplanar. Good. All right. So let's talk more about parallelism. So I've got these two lines right here. I've got line AB and I've got line CD. So I know that these two lines are parallel to each other. It means that they never intersect. And so the way that I would indicate that, remember how we've talked about like the way we say that two things are congruent to each other, and we got the little congruency sign, or similar to each other, and we got the little similarity sign. So we have a new sign for parallelism. And if I know that AB and CD never intersect, I can write that. Isn't that kind of cute? It's like two little parallel lines. So great. All right. So I would say that AB is parallel to CD. Another way that I indicate that on my figure is I would draw a little arrow like this. So it's not going to be like the congruency signs. They're like little arrows. And if I have two lines over here and I want to indicate that they are parallel to each other, but they are not parallel to line AB and line CD, what do you think you do? You double it up. Woo woo! So then I know that these two lines are parallel to each other and not parallel to the other ones. Cool. Another thing that we'll do sometimes is we'll call a line line L or a line M. And so another way to write that these two lines are parallel to each other is you can write just literally line L is parallel to line M. So this is just important notation for you to get comfortable with. And then obviously if you have like a third pair of lines that are parallel to each other and they're not parallel to the other two, you would do 3 arrows, 4 arrows, 5 arrows, 6 arrows, whatever. Good. All right, scooching on. Scooching on. So if I have two lines and they are cut by what we call a transversal. So this transversal in this situation is this red line. So a transversal just means the line that is crossing the two lines that we're interested in. Now these two lines are not parallel to each other, and that's totally fine because there are a set of angles that are created by these two lines and by the crossing transversal, and we want to get comfortable with what those angles are. So alternate interior angles, let's talk about those first. Alternate interior angles are going to be on alternate sides. So like this angle and this angle, and they're not necessarily congruent to each other in non-parallel lines. And in fact, they're not parallel, so not congruent to each other in non-parallel lines. So alternate interior angles means the two angles that are on opposite sides of that transversal and inside the parallel lines. So instead of marking it like that, I'll do like this. And then you've got another pair of alternate interior angles, this one and this one. You've got a pair of same side interior angles. Same side means the same side of the transversal and inside the parallel lines. So this one and this one would be our same side interior angles. And then corresponding angles are a little tricky. So corresponding angles, if you think about chorus and how you all line up and you stand in the exact same line like this, all in the same position, corresponding angles are always going to be in the same spot. So I'm going to talk about this angle right here. I'll give it like a little different star. So that angle right there has the transversal on its left and then the black line down below. There is another line that is there's another angle that is in the exact same position, and that's this one. See, I've got the transversal right there, and I've got this black line. So these two are what we call corresponding angles. This will make a little bit more sense when we talk about when we know that the two lines are parallel to each other. So look at this. So now I've got two lines that are parallel to each other, and I've got this red transversal again. So if you look at, let's say, like your alternate interior angles again, So here is an alternate interior angle. Whoop. There we go. So here's an alternate interior angle. Here's another alternate interior angle. Don't ask me how I just changed the color of the transversal. No idea. So I'm going to click this transversal. And if I start to squash it and move it around like this, look what happens to my alternate interior angles. Are you noticing anything? They are staying the same. So this is something that is really, really important. When our lines are parallel, a really cool association happens between our alternate interior angles, our corresponding angles, and our same side interior angles. And those associations are postulates, and they are called AIP, CAP, and SUP. We will get there in a second. So let's start off with CAP, so CAP. So this is what we call the corresponding angle postulate. And remember, corresponding angles are in the exact same position. So if I look at angle 2, let's say, so there's angle 2. If I take angle 2 and think about chorus, and if I take angle 2 and I shimmy this guy all the way down, so watch. If I take him and I go all the way down, do you see how angle 2 matches up perfectly with angle 6? We would consider angle 2 and angle 6 to be corresponding angles. And because I know that AB is parallel to CD, those two lines are parallel to each other, I know that my corresponding angles are going to be congruent. So this is what the CAP, the CAP, tells us, that corresponding angles are congruent to each other. Pause the video, and I want you to figure out if there are other pairs of corresponding angles. Go. All right, we're back. So hopefully you figured out that angle 1 and angle 5 are corresponding angles, and they're congruent to each other. Angle 3 and angle 7 are corresponding angles, and they're congruent to each other. And angle 4 and angle 8 are corresponding angles, and they're also congruent to each other. So that's CAP, or CAP. All right, next one. Now we're going to jump into AIP. So AIP deals with alternate interior angles. So it's the alternate interior postulate. So the alternate interior angles, look at this. We know that our lines are parallel to each other. So here, angle 4, the alternate interior angle to angle 4 is which one? Pause the video, get back to me. All right, we're back. So the alternate interior angle to angle 4 is angle 5. They are congruent to each other. The other pair of alternate interior angles is angle 3 and angle 6, and they are also congruent to each other. So one little cute way, because it's so cute, one little cute way to think about this is if you were to highlight angle 3 and highlight angle 6, see how they make a Z? So one way to remember is AIP makes a Z. AIP makes a Z. Now, 4 and 5, if you were to highlight those guys, they still make a Z, but it's just kind of flipped and backwards. But AIP makes a Z. So I know that alternate interior angles are also going to be congruent to each other. So corresponding angles are congruent and alternate interior angles are congruent. And remember, this is only when we know that lines are parallel to each other. All right, here we go. So here's the last one. This is same side sup. So here's what we know. I have same side interior angles. So so I've got angle 3 and I've got angle 5. These are same side interior, same side of the transversal, and they are inside my parallel lines. These guys are not congruent to each other, but they are supplementary. So I know that the measurement of angle 3 plus the measurement of angle 5 equals 180 because of def sup. Cool? Pause the video. Tell me if there's another pair of same side interior angles. Go. All right, we're back. So hopefully you figured out that angle 4 and angle 6 are also same side interior angles. Because my lines are parallel to each other, I know that they're supplementary. That's called sup or same side sup. Awesome. All right, so now I want you to pause the video and solve for x. Okay, we're back. So hopefully you figured out, oh, look, I've got my parallel lines. So I know that this guy is parallel to this guy. And then here is my nice little transversal. I'm going to color it in green. The green responds. Nice. And so look, do you have anything that makes a Z? You do. So you've got nice little alternate interior angles. AIP makes a Z. So hopefully you figured out that 2x equals 42, and you were able to solve this out. And you got that x equals 21. Good job. All right, on to the next one. So all the things we talked about before, AIP, CAP, and same side stuff, those all were if we knew that lines were parallel to each other. So now let's think about the converse. Let's say that we were trying to prove that two lines were parallel. So now this is just the converse. So if I'm able to prove that this angle and this angle are congruent to each other, if I know that, then I know that line AB and line CD are parallel. That would be the cap converse. Now, let's say that I was able to prove that this guy and this guy were congruent to each other, then I would know that AB is parallel to CD because of the AIP converse. And then the last little one is if I'm able to prove that this angle and this angle are supplementary to each other, then we'd have the same side sup. Sorry for the delay. Converse. Those are just like little ditto marks, not parallel line marks. So AIP converse, cap converse, and same side converse. Those would all prove to us that lines are parallel to each other. Excellent. All right, so now I want to take a peek at this. So I think this is really fun. So when you're given problems like this, what you're trying to do is you're trying to figure out which two lines are parallel to each other. So let's say I told you that the measurement of angle 13 and the measurement of angle 11, those guys are equal to each other. So I've got angle 11 and angle 13. So do you see how I highlighted both of those? See how they share this line? Whatever line they share, that's the transversal. And the two lines that are left over, those are going to be your parallel lines. So if I know that 13 and 11 are congruent to each other, then I know that line L is going to be parallel to line M. I want you to pause the video and try it for the next one. Measurement of angle 13 equals measurement of angle 6. Go. All right, we're back. So let me go ahead and erase what I have from before. And so for this one, hopefully you got this. So you had 13 and then you had 6. They share this guy. So you know that that's going to be your transversal. I'm going to switch to green. And so then whatever's left over, boom, boom, those are going to be your parallel lines. So hopefully you got that N and P are parallel to each other. All right, last little bit. I want you to just try this proof. Pause the video and try it. Okay, we're back. So we've got your given information. And so the given information is that SQ bisects AQR. So I know because of definition of bisector, I know that these two guys are going to be congruent to each other. And I know that AQS is isosceles. But the base here is QS. So careful. The base is QS, which means that AQ and AS are congruent to each other. And so if we want to prove that QR and AS are parallel, so I want to prove that this guy and this guy are parallel to each other, you've got to think about, well, what pair of angles are going to be congruent? So hopefully you've got your givens on there, you've got your definition of bisector, which we just walked through. Then we've got definition of isosceles, which we just walked through. And then we have if sides then angles. So watch this little piece right here, the if sides then angles, right, y'all? So this would tell me I know that this is congruent to this. But wait a second. If angle S is congruent to angle AQS and angle AQS is congruent to angle SQR, what do you know about angle S and angle SQR? You know that they are transitive. They are congruent to each other. So looky-loo, you know that you've got these two angles that are congruent. You've got these two angles are congruent. And look, you've got a little Z there. So you know that these two lines are parallel to each other because of AIP converse. AIP makes a Z. It seems a little tricky, but I promise you'll get into a groove. Go ahead and tackle the homework, and I'll see you soon. Thanks so much.